The dawn of another day at Mahindra Hinoday. The clinking sound of metal and charged up employees reporting to duty. The morning activities set the pace for the day. Lively discussions in the canteen often serve as food for thought as the day breaks. The giant machinery that moves sand, metal, etc. starts chugging along, and the entire campus comes alive to another eventful day. Mahindra Hinoday Industries Limited, MHIL, today is the largest ductile iron non-captive foundry at a single location with a staggering 70,000 ton capacity spread over 3 plants. Started as a joint venture between DG Piramal Group of India and Hitachi Metals of Japan in 1996, Hinoday became a part of Mahindra Systech in 2007. The word Hinoday was coined using Hino, the Japanese words Hi and No, meaning of the sun, and Uday in Sanskrit means the rise. Thus, Hinoday means the rising sun. Hinoday is a brand with firm Indian roots, but with an enviable global spread. No wonder this journey has seen Hinoday gradually increase its direct exports to 20% with varied destinations like US, England, Romania and China. Hinoday is proudly associated with demanding and industry leader customers like Cummins, Honeywell and JCB. Hinoday went full length into supply chain by establishing warehouse facilities at places near point of consumption. The foundry is strategically located on the Pune-Mumbai Expressway and is easily accessible from the Mumbai, Pune and upcoming Chakan International Airports. Hinoday is ISO TS 16949 certified by BVQS and aiming at ISO 14001 by December 2012. We are the first in India to use auto pouring system with automatic inoculation, CAD/CAM process for tool design and manufacturing, use of cold box process in mass production, casting process for producing cast crankshaft for passenger cars, and high pressure line for ductile iron by an independent foundry. The manufacturing setup at MHIL comprises 3 different plants, each with its own sand plant, core making, molding, melting and finishing facilities. These are called as NL0, NL1 and NL2, NL3. The basic manufacturing process comprises molding, core making, melting, shot blasting and finishing, and machining, followed by packing and dispatch. Melting. The charge preparation involves mixing of steel scrap with foundry returns into a vibrator. The vibrator empties this charge into a furnace with other alloys and additives. The molten metal bath is poured into a treatment ladle containing nodulizer, which converts it into spheroidal graphite iron, also known as ductile iron. This treated metal must now be poured into molds before magnesium fades away. The chemical composition of the bath is checked before and after treatment to ensure exact chemistry. The treated metal is emptied into the molding boxes through an auto pour or pouring car. A test bar is also taken to confirm the mechanical properties. Molding. The technology is horizontal parting high pressure green sand molding. Green sand is compacted into the required casting shape created by the pattern tooling. Critical sand parameters like green compressive strength, loss on ignition, compactability, mold hardness, clay content and composition, etc. are rigorously monitored for every batch of sand. The molding machines are from DISA. Core making. Cores are used to create cavities inside a casting and also to achieve complicated profiles. Hinoday manufactures both cold and shell cores. The design of the core box is done in-house using software like Pro-E, CATIA and UG. The manufacturing is outsourced to ISO certified vendors. The cross-functional team, CFT, takes care at the design stage to optimize the core weight so that the customer gets benefited. The core shop comprises a number of core making machines with horizontal and vertical parting lines as per the part requirement. The capacity varies from grams to a few kilograms. At the final stage, the cores are inspected, dressed and painted before being passed on to the molding line. Turbine housing cores are necessarily passed through a height gauge for correct thickness. The flaskless lines use core masks for core setting. Finishing. The molten metal cools in the molting boxes with predefined cooling period. Hydraulic wedges are also used to separate casting from the casting tree. Then comes shot blasting on batch type and hanger type DISA shot blasting machines. The shot blasted castings follow a single piece flow system for minor rework, grinding, burr removal, etc. They are then sent to dispatch after visual inspection and oiling. Design and development. Hinoday does the tooling design in-house using the latest softwares like CATIA, UG, Pro-E and flow simulation softwares like ProCast. These help us optimize the casting weight and achieve first-time right product. After receipt of part drawing, the CFT carries out brainstorming with the specifications and digs into past things gone wrong, things gone right for a similar product. It carries out simulation on the solid model to decide the gating system which is at the heart of a defect-free casting. We follow the standard APQP process for sample, PPAP and serial productions. In case the part is machined at a vendor's premises, the vendor is also a part of this process. Often the development team has to work under impossible deadlines, but quality is never a compromise. Quality assurance, QA. The QA lab is equipped with sophisticated equipment like ZES Coordinate Measuring Machine, LECO CS Analyzer, Shimadzu Vacuum Emission Spectrometer, Tensile Strength Machine, Brinell Hardness Tester PC Model, Image Analyzer, Surface Roughness Tester, Microscope, Sand Testing Lab, Scratch Hardness Tester, DFT, Dry Film Thickness Meter. Machining. As a forward integration policy, Hinoday installed its first in-house machining cell in 2006 for machining of high-end products like turbine housings. The machine shop comprises of a number of high-tech CNC, HMC, VMC, leak testing, washing, and wastegate assembly machines. The single-piece flow process starts with number marking on each part for 100% traceability and follows fixed machining sequence. Post-machining, it is subjected to aesthetic and dimensional check on multi-gauging. Many turbine housings are supplied as sub-assemblies with welding assembly of child parts. These are then 100% checked for pressure test, oiled to avoid rust, and packed in export-worthy packaging. The in-house installed capacity is 700,000 numbers per year. The machining division has a full-fledged development team in place which coordinates with the central CFT during product development. Turbine housing being a challenging product, Hinoday often adopts the turnkey approach while ordering the machines, tooling and fixtures with inbuilt Pokayoki, which offers the customer a complete solution. Hinoday also has an established base of ISO certified vendors who machine parts like bull cages, manifolds, hubs, turbine housings, brackets, front engine supports and bearing caps. Familiarity with overseas business, familiar with EDI, electronic data exchange and global RFQ, RFI, global bidding process. Familiar with VMI, vendor managed inventory at contracted warehouses in UK, USA. Facility for full container shipments and factory stuffing with bar coding. Well versed with global OEMs quality requirements. Well connected to the world's major customers through Systech Associates. Hinoday is a brand that has changed the way the foundry business is looked at in India, be it the products or technology. Hinoday stands tall amongst the glut of Indian foundries. Hinoday has been amongst the last to start a foundry business, but today its credentials are none to better. It has lived up to the Mahindra spirit of rise, which means accept no limits, drive positive changes and think alternatively. At Mahindra Hinoday, the philosophy is rise each day, each morning.